This is homework number 6, and this is part 2 of graphing the function for problem 9, f of x equals x squared plus 2x plus 6. So in the last video we made our note card, and we've got our steps for graphing this function. So the first step is to find the vertex, and that's using this little formula when the function is in this form. And our function is in that form. We've got an x squared term, and I could put a 1 in front of that for the coefficient a. We got a b term, an x term with the b value 2, and we have a c, or constant term. So my formula for the vertex is x equals the opposite of b over 2a. Let's start plugging and chugging. X equals the opposite of b. Oh, wait, gotta make my little chart over here. A equals 1 and b equals 2. Now I don't need c because it's not in the formula. Alright, so opposite of b. B is 2, so the opposite of b will be negative 2. Over twice a. 2 times a is 1. And when I simplify that, I get negative 2 over negative 2. Negative 2 divided by 2 equals negative 1. So what I've just found is the x value in the coordinate pair that we call the vertex of this parabola, where the parabola turns. Next, I need to do step 2, which is to plug that x value from step 1 back into the function to find the y value, the output. So negative 1 is going to go here wherever the x is. So I'm going to be finding f of negative 1. F of negative 1 equals 1 times negative 1 squared plus 2 times negative 1 plus 6. Again, I've just taken my function, taken the x's out, and put negative 1's in their place. Negative 1 times itself, do the exponent first. Negative 1 times negative 1 is positive 1. Positive 1 times this 1 just makes positive 1 again. You can use your calculator if these steps are confusing you. 2 times negative 1 is negative 2 plus 6. Now let's add from left to right. 1 plus negative 2 is negative 1, and negative 1 plus 6 is positive 5. Alright, what I've just found in the second step is the y value, the output for the x value, negative 1 in my function. So right now I've got my vertex, negative 1, 5. So I need to get a graph ready. And let's make sure we have at least 5 spaces above the x-axis, y-axis. We're going to plot the point negative 1, 5. So from 0, 0, left 1 and up 1, 2, 3, 4, 5. And this is my vertex, negative 1, 5. Alright, let's look at our note card. We've done steps 1, 2, and 3. We found the x value of the vertex, the output or y value of the vertex, and we plotted it. I can't count, this is step 4. Step 4 is to make a t-table with a vertex in the middle, find pairs each side of it. So our vertex that we just found, negative 1, 5, is going to go right here, and we're going to find some coordinate pairs that work in the function on each side of that. So right here to the left of my graph that I've started, input x, output f of x, and let's get this table ready for some coordinate pairs. Okay, in the middle, somewhere in the middle, I'm going to put negative 1, 5. Input, output. This was a point on my graph. And so going this way, 0, 1, 2, and this way, negative 2, negative 3. And if I needed, I could squeeze negative 4 in there. We'll see what this looks like as I find these points. So now I'm going to try each of these input values in the function to get an output and plot those pairs. So let me write my function down again. Alright, and we're going to start by finding f of 0, because that's really an easy one to do. F of 0. So I'll be putting 0 wherever the x's are. And usually when you're plugging 0 into a function, it goes pretty quickly, because 0 squared is 0 times 1 is 0. 2 times 0 is 0, and all that's left is 6. So f of 0 is just the constant value, the c value at the end of the function. So I just plugged in 0, I found f of 0, and I got the output 6. Alright, now let's find f of 1 from our table, f of 1. And so that'll be 1 times 1 squared. Again, I'm going back to the function, and wherever the x's are, I'm putting the value I'm sticking in from my t-table, my input, plus 2 times 1 plus 6. So last time we put in zeros, this time we're putting in 1s. 1 squared is 1. 1 times 1 is 1. 1 times 2 is 2. 1 plus 2 plus 6 is 9. So f of 1 made 9. Alright, and in the table it goes. I'm going to skip this one for now. I might not need it. Let's go backwards and do f of negative 2 now, because you're going to see a pattern here that's going to help you do these more quickly. So again, I'm going to take that function, 1 times x squared plus 2 times x, oops, I'm going to put a pocket there, plus 6, and wherever the x was, I'm putting a negative 2. And I kind of goofed this up here. Hopefully you can see that that's going to be a negative 2 there. Alright, negative 2 times itself is positive 4, and positive 4 times 1 is 4. Plus 2 times, that was a negative 2 in there. 2 times negative 2 is negative 4, plus 6. Okay, negative 4 and positive 4, these two make 0. And that gives me just 6 then. So f of negative 2 was 6. Interesting. So was f of 0. I'll go put that in my table. I put in a negative 2, I got a 6. We shouldn't have to do more than one more. We're going to put in the negative 3 now. So now again, it's 1 times where x was, put a pocket, plus 2 times where x was, put a pocket, plus 6. So it's the same function over and over again, and this time we're putting in the negative 3 from the t-table. Negative 3 squared is 9. Negative 3 times negative 3. So I'll have 9 plus 2 times negative 3 is negative 6 plus positive 6. The negative 6 and positive 6 when added together make 0. And so f of negative 3 is just 9. F of negative 3 is 9. Now, let's put that in our table. I don't need this one. Here was our vertex in the middle, and I found inputs and outputs for 2 values on each side of that. And look what the pattern is. 9, 6, 5, 6, 9. From the vertex it goes up this way, it goes up this way and up this way. So let's finish plotting this now, and I'm wishing at this point that I'd made my graph higher. So let's see if we can make this work. 0, 6. This is go up, I go right or left. 0, up, 1, 2, 3, 4, 5, 6. Negative 2, 6. So from 0, left 2, up 6. So that would be the same height as the last one I plotted. Let's go over here and do 1, 9. So right 1 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then left 3, 1, 2, 3, and up 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is about all we need, because I know this is going to be a parabola, and if I connect these points with a nice curve, I see that it's symmetric about that vertex. That the value to the left and to the right in the t-table also are symmetrical on the graph. And so are the next two pairs. Parabolas are really easy to graph. I have one more step, and that is to find the minimum or maximum. The minimum or maximum. So that's the highest or lowest point on the graph. Well, it's not going to be a maximum because the graph continues into infinity from, if you were trying to find a maximum. And so there will be no maximum. It goes on and on forever. But right here at the vertex, there happens to be a minimum. So the minimum is, and we just named the y value there, is 5. This is the lowest this graph goes. It goes down to 5 on the y-axis. And we are finished graphing our parabola.